All right, let's go, people. All right, so what we've done so far is I have taught you most of the basics of limits. All right, and that's what we went through with those worksheets and everything. But now we're going to start applying them to word problems, okay? And that's almost always the harder part, no matter what math you do, it's always the word problem stuff, okay? So, for example, this first equation that we have up here, average change equals that triangle means change in y over change in t, and the change in y equals f of t plus the change in t minus f of t all over the change in t. Now, use what you already know. That should sound like an equation that you already know, believe it or not. You are really close, actually, Eli. You're closer than what you think you are. Except it starts with an S. No, not simple formula. Well, it kind of is. It's one of the first algebraic formulas you guys learned. Nope. Good try. Well, it kind of. Kind of. What was that? I think somebody said it. Slope. Average rate of change. This change in y, if I change this t to an x, isn't this y2 minus y1 over x2 minus x1? All right. Y is your distance. T, or x, is your time. So whenever you see average rate of change, you should be thinking some kind of slope, okay? And the only reason I say that is because you guys already understand slope. All right, so that's all this average rate of change formula is here, is it's just your slope equation. All right, and that's going to be the case for the whole year. All right, so down below we have a question here. An object drops from rest from the top of the school, falls at y equals 16 t squared feet in the first t seconds. Find the average speed during the first 5 seconds of the fall. All right, well, to find slope, we've got to have 2 points, right? If I plug a 0 in for t, what is y going to equal? It's going to equal 0. And then I've got to use a 5 here. If I plug 5 in there, what do I get? Thanks for figuring out. Let's go. It is not 16. Let's go. Plug 5 in here. Let's go. 400. All right. So then from here, we just do the slope of those 2 points. So 400 minus 0 over 5 minus 0, whatever 400 divided by 5 is, which is okay, and average speed, what would I put for my label then? Use what we know. What did the y's, right? This up here was talking about feet. The bottom is talking about, we would have 80 feet per second. Okay, so average speed, you have to figure out your 2 points. You always start with whatever your starting is and whatever your ending is. And then use your slope formula to be able to figure it out from there. Now, there is 1 word difference between that one and this one. Very good, Eli. All right, write it down. Let's go. Find the instantaneous speed of that same object that is falling at y equals 16t squared at time equals 3. So what instantaneous means is how fast is it going exactly at 3 seconds? Drew, what do you think you do?
You take that 3 and plug it in the 8 at the 16t squared.
Yep, that's all you do. So, hold on, 16 times 3 squared equals, what'd you say?
144.
144. And then it's still the same thing here. It's feet per second. Okay. So average average speed, you have to more or less use the slope equation to get your average speed over a certain amount of time. Instantaneous speed, you plug it in to figure out how fast you're going. All right. Any questions between the two? All right. The rest of this is a lot of review, to be honest. All right. Find the following limits.
Let's see.
Write them down, get them solved. Let's go. The first one and the bottom one you should be able to do with no problems whatsoever.
I like to go on record.
The second one, well, I'm pretty sure that means you can still do the first one. The second one, you need a little help with it. Matt, what do you think you do there? That's all you do. Yeah. There's your answer for number one, right? You just plug in a C wherever you see an X. I mean, technically, we should check and see if we can simplify. I don't think you can here. So we're going to skip that. All right. Go down and do the bottom one here. All right, Drew, what are you doing? You're typing this in your calculator. I'm pretty sure we can go -4 plus 3 is how much? Thanks, Ethan. -1 to an even power. It doesn't matter how big it is. The even power will turn this into a positive 1. Okay? Hey, none of that. All right, now if that were an odd power, what would the answer be?
-1.
Very good. Okay. All right. Any questions? All right, now the second one up there. All right, remember, very first thing that we do is we plug in a 0. So if we plug in a 0 for tangent here, tangent of 0 is 0 over 0. That means we got to do something else, right? Now, one thing that we can do is tangent is the same as what over what? Very good. Sine of x over cosine of x. And that's all over x. Well, we have a fraction inside a fraction. We could rewrite this. We could say this top fraction is divided by x, which would mean we would have sine of x over cosine of x times 1 over x. All right, now, what else we can do at this point is, and I'm going to tell you why in just a minute, but we're going to flip, you guys know with multiplication, we can rearrange the order at any time. So we're going to move these two, the cosine of x and the x. So we get the sine of x over x times 1 over cosine of x. Okay, now I'm going to tell you why in just a second here. Okay. Now, this only works when x is approaching 0, but the limit as x approaches 0 of sine x over x is 1. All right, so that's a rule that you're just going to have to get memorized. Sine x over x equals 1. Same thing as x over sine of x also equals 1. Okay, and that's why I rearranged the order down here. Okay. And that's also why I told you that you probably couldn't do this one yet, because we hadn't talked about this concept yet. Okay, so get that in your notes. And that's one that you can prove graphically. I mean, obviously, if you throw a 0 and a 0 in here, this would be sine of 0 is 0 over 0. All right, it's one of those rules that I hadn't taught you yet. All right, just like the one that McKenna asked on 14. Okay, now I could prove this algebraically, but that's something else that I have to teach you yet before we can do that. Okay, so we're just going to take this as fact right now, and then later on I'll teach you algebraically how this works. Okay, so if we know sine of x over x, the limit as x approaches 0 of this thing is 1 times 1 over cosine of 0. Well, how much is cosine of 0? 1. We have 1 times 1. I'm pretty sure that equals 1. All right, so what we went over with this, a little bit of new stuff. First of all, we have to know this limit equals 1. And then we have to split this tangent into sine over cosine. So you'll see that a little bit in your homework off and on. That's always a rule that you can do. It's very similar to if I said like cotangent of x, well, we can say that that's cosine of x over sine. All right, or like many times what you guys have done in the past, cosecant of x, well, that would just be 1 over sine of x. All right, so normally, if at all possible, if you can turn this into some kind of an equation that cosine, most of the time these are going to be easier. Okay, so like I said, you might see that a little bit in the homework today. All right, any questions so far? All right, the other limit problems that you guys are going to see in your assignment today is really just a review of what's been asked the last week in the worksheets that you guys have been doing. All right, outside of this. All right, so I don't know if you need to write this down, but we can evaluate a limit based on looking at the graph. All right, so we've got some kind of curved shape here coming in to -2 at x equals 2 from the left, and then we've got some kind of curved shape on the right side also. Okay, now we want to answer all 5 of these questions first of all. Okay, the limit as x approaches 2 from the right is what? What do you think? No. 2 from the right. So we are evaluating at x equals 2 here. From the right side, that means we're coming up here. Yeah, whatever the y value is at this point. So this would be a 5. Yes, if you get an infinite amount of yards in a football game and 5, it's the same thing. Right? All right, next one. 2 from the left side. What would 2 from the left side be? -2. Yep, we're coming in from the left side. We're coming in, and it gets really close to -2 here. What's the limit from both sides? Limit from the right side, limit from the left side. What has to happen for you to have a limit?
They are the same.
They have to be the same. Are they the same here? No. So what's our answer? Yeah, does not exist because they don't meet at the same point from each side. Okay, and really all we have to do is we have to look at these two right here, and because those two are not the same, that's why the limit doesn't exist. All right, domain. What's the domain? What are all the x values that are going to work here? Everything. Yep, so you could say all real numbers. What about the range? It is also everything. Now for the domain, yep, we have a hole, but this hole gets filled up by this, right? Okay, for the range, it's the same concept. Yes, we have a hole here, but it also works there and there. So it would be all real numbers also. Remember how the book is writing these are for both of these. It'd be negative infinity to positive infinity. All right. Any questions? All right, homework assignment.